Hi folks, welcome to 6.4 multiple angle formulas. So in this first video, we're going to talk about double angle formulas. Let's start with the double angle formula for sine. So if you think back to the last unit that we talked about, 6.3, we learned that there was a sum formula for sine. And that sine of u plus v equals sine u, sine u cosine v plus cosine u sine v. And so we're going to take that and extend that to a special case where we have a double angle. So let's say that we had sine of u plus u. Another way to think about that is u plus u gives you 2u, or a double angle. And if we plug that into the formula, we'll get sine u cosine u plus cosine u sine u. And we can actually simplify that right to 2 sine u cosine u. And that's going to be our double angle formula for sine. So sine of 2u can equal 2 sine u cosine u. Okay, what about cosine u? Well, in the last section we learned that cosine of u plus v is going to equal cosine u cosine v minus sine u sine v. So let's do what we did with sine, and let's just plug in a u plus u to give us the double angle 2u. So I'll get cosine u minus sine u sine u. And I can clean that up to be cosine squared u minus sine squared u. And this is the first of 3 variations of the cosine double angle. Now, where do the other 2 come from? It turns out that we're going to use our good old friend sine squared u plus cosine squared u equals 1 to generate the other 3 versions. So one thing I could do is I could say, well, I know that cosine squared u equals 1 minus sine squared u. And so in my equation, everywhere I see a cosine squared, I would put 1 minus sine squared. And then I have the minus sine squared that was already there. And I could condense that to be 1 minus 2 sine squared u. And this is our second variation of the cosine double angle formula. But what happens if instead of isolating cosine squared, I isolated sine squared? That would make sine squared equal to 1 minus cosine squared u. And I'm going to go ahead and plug that into the original. So I have cosine squared u minus our substitution for sine squared, which is 1 minus cosine squared u. And now when I clean this one up, I'll get 2 cosine squared u minus 1. And that is our third variation of the cosine double angle formula. Okay, let's move on to tangent. So if I wanted to find the tangent of 2u, so a double angle, I could just do sine of 2u over cosine of 2u. That's totally valid. And I could even say, instead of sine 2u, I want to write 2 sine u cosine u, which is the formula from the first slide. And down here, I could pick any of the 3 variations for cosine 2u. And that's really up to you. There is a simplified formula in case you're working with tangents, and that looks like this. 2 tan u over 1 minus tan squared u. And so any one of these would be okay to have as your tangent double angle formula. So let's go ahead and take a look at this summary slide. So the double angle formulas that we know, we have the sine 2u, we have 3 variations for cosine 2u, and then we have our tangent 2u. Make sure that gets on your list of things to study. Okay, let's try a few problems. Example 1. If sine alpha equals 4 over 5 and alpha is an acute angle, find the exact values of sine 2 alpha, cosine 2 alpha, and tangent 2 alpha. Now, because they're asking us for the 2 alphas, they're asking us to use the double angle formulas. And let's see what else they tell us. Well, they give us our sine of the angle, and they tell us it's an acute angle. And to me, when someone says it's an acute angle, I know that's in quadrant 1 because it has to be between 0 and 90 degrees. So let's draw a right triangle, label it, and then get started. So let's say here's my alpha. If sine equals 4 over 5, that means the opposite side is 4, and the hypotenuse is 5. Now, we've seen this triangle quite a bit, so by now, I hope we know this is a 3, 4, 5 triangle. Once we've drawn our triangle, now we're just going to write out the formulas, plug in the numbers, and simplify. So let's start with sine of 2 alpha. I know that formula is 2 sine alpha cosine alpha. So 2, and I'm actually going to write that 2 as 2 over 1, just because we're going to see a lot of other fractions, and sometimes life is easier if they're all fractions. So sine of alpha, according to our triangle and the information in the problem, is 4 over 5. And cosine alpha is the adjacent, or 3, over the hypotenuse. So it all goes back to your SOHCAHTOA. Let's clean this up a little bit. I'm going to multiply straight across on the top and on the bottom, and I will get 24 over 25 for the sine of the double angle. Okay, now let's take a look at the cosine. So cosine of 2 alpha, I have 3 versions to choose from, but if I'm adding fractions, I like to pick the cosine squared minus sine squared because it'll give me a common denominator right off the bat. And so when I work through this, I'm going to get cosine is 3 over 5 squared minus sine is 4 over 5 squared. And that is going to give me 9 over 25 minus 16 over 25, which will give me negative 7 over 25. Okay. Now, if I have sine as positive and cosine as negative, I know that my tangent should also be negative. And since we already have our sine and cosine values, I'm just going to take my sine 2 alpha and I'm going to divide it by my cosine 2 alpha. And so that will give me 24 over 25 over negative 7 over 25. And if I break that down more, I get 24 over 25 times the reciprocal, which is 25 over negative 7. And so this will give me a tangent to alpha of negative 4 over 7. Okay, now as a quick check, if I have a positive sine and a negative cosine and a negative tangent, that actually means that my double angle is in quadrant number 2. okay? And I know it's in quadrant number 2 because sine is positive, cosine is negative, and tangent is negative in that quadrant. Okay, let's try another example. So if tangent alpha equals -3 and alpha is in quadrant 2, find the exact values of sine 2 alpha, cosine 2 alpha, and tangent 2 alpha. And this time, I want us to make sure that we determine the location of 2 alpha. So let's get started. I know that my triangle or my angle is in quadrant 2. So I'm going to go ahead and draw my right triangle. And I'm going to label this as alpha. And I know that tangent is really opposite over adjacent, which is really -3/1. And so when I think about my alpha, I'm going to label the opposite as 3, because that's a positive direction, and my adjacent as -1. And when I use a squared plus b squared equals c squared, I will find that the hypotenuse is the square root of 10. Okay, so let's go ahead and find our sine 2 alpha, cosine 2 alpha, and tangent 2 alpha. So sine 2 alpha equals 2 sine alpha cosine alpha, which equals 3/√10 times -1/√10, which gives me -6/10, which I can reduce to -3/5. Okay. Let's find our cosine 2 alpha. So cosine 2 alpha, I'm going to use 1 minus sine squared alpha this time. You can use the cosine squared minus sine squared. I like that one better, but I just want to show you can do it with more than one option. And so this gives me 1 minus 3/√10 squared, which gives me 1 minus 9/10, which gives me 1/10 for my cosine. Okay, tangent 2 alpha equals sine 2 alpha over cosine 2 alpha, and that means I have -3/5 over 1/10, which gives me -3/5 times 10/1, which gives me -6. And so I need a quadrant where sine is negative, cosine is positive, and tangent is negative to find the location. And the quadrant that satisfies that is quadrant 4. Okay, we're going to pause here, and when you come back for video number 2, we'll take a look at some more examples. See you there.